video, we will prove and show examples of how to find the derivative of a constant and the derivative of a linear function. First of all, the derivative of a constant is f of x equals c, just some number. How does that look graphically? It's a horizontal line. You can also think of it as a function with no slope or zero slope. So instead of mx plus b, it would be 0x plus c, our constant. These are equivalent functions. All right, let's plug it into the limit definition to figure out how to find the derivative of a constant. We're going to plug in x plus delta x anytime we see the input of x. I see it right here. So 0 times x plus delta x plus c minus our original function minus 0x plus c all over delta x. Continue to algebraically reduce or simplify. 0 times anything is 0. We have c minus 0x is also 0, so what's left in this is minus c all over delta x. We can continue to simplify before even using substitution. C minus c is 0. You don't have to use direct substitution to solve this limit because 0 divided by delta x is 0. If you can simplify algebraically first, then direct substitution isn't needed. The limit of a constant as x approaches anything is simply that constant. The derivative with respect to x of a constant is equal to 0. This actually makes sense logically because derivative is slope. A constant function gives us a horizontal line. A horizontal line gives us a slope of 0. Therefore, the derivative of a constant is 0. Use this to find the derivative of 3. 3 is a constant, just a number. So the derivative is 0. What is the derivative with respect to x of negative 2? Also 0. The derivative of a constant is 0. To find the derivative of a line, we're going to plug in our most famous form, which is mx plus b. Looking at it more from a polynomial standpoint, you can call it ax plus k or vertical shift k. I'm going to use mx plus b because that is the most familiar to us. So anytime you see x, you're going to input with x plus delta x. So we should have m times, instead of x, the quantity x plus delta x, plus b, subtract the original function, mx plus b. Remember to subtract that quantity, distribute that negative. So we're going to distribute and simplify the numerator as much as possible. Mx plus m delta x plus b minus mx minus b. B minus b is 0. Mx minus mx is 0. Okay, we have delta x approaches 0. M delta x over delta x. Hey, delta x divided by delta x is just 1. So we're left with m times 1. The derivative with respect to x of some function mx plus b is equal to the limit as delta x approaches 0 of m. That would simply be m. Logically speaking, the derivative is slope. Slope of a line is always m, so the derivative of a line is its slope, m.